Hello and welcome to class number 7 of Advanced CAD. Today we'll be looking at assembly motions and mates. Specifically, we'll be learning the width mate, the limit angle mate, and the gear mate. We will not be getting into the pattern driven component pattern or the radial explode. However, if you have free time and you're willing to do that example, it is very cool. So let's just get right into it. First, we load up the Heliodrone assembly from our class files. And I will turn off my origins to make it cleaner. First step is to position these so that they're between these two walls. To do that, we use the width mate. So we come up to the mate command. We go to the advanced mates and we select width. I don't want that face on there. We want to pick the side faces. And then we want to pick those similar faces on the wing. And it automatically centers that in that slot. It doesn't matter which you use for the width or the tab. I'll show you that by selecting this surface as the width and this surface as the tab. And again, it centers it in that slot. Now we just position the motors in the receivers on the wing. To do that, we come back up to the standard mates, select the pin, select the receiver where that pin will go, and it automatically infers that you want a concentric mate, and you select OK and it goes into position. Do the same thing on the other side, and it goes into position. Now you can see that we have them on the wing and it spins all the way around, even goes right through the wing. So we're going to set a limit. We're going to set a limit so that when you can swing it all the way up, but it's going to stay horizontal or parallel with the wing. And when it swings down, it's going to swing down just before that support, right about there. So to do that, we go back up to mate. We're going to go back to advanced mates, and we're going to say we want an angled mate. So we're going to select a plane that's parallel to what we want the maximum to be, in which case it will be the top plane. And the surface that's going to be parallel with that will be this flat plane here. It only works because it's flat. And we're going to say that our maximum angle is, where we have it now is 82. The book says 83. Make it 83. So our maximum angle here will be 83. Our minimum is going to be this top plane, which is going to be 0. So now this motor will swing up just that far and swing down just enough that it doesn't hit that support. But right now both of these motors are working independent. This one still swings all the way around, and this one only swings up and back. To make them the same, we could add that same constraint here, but to make it easy, we'll just select this surface and this surface, go back to standard mates, and be a parallel or coincident. Either one will work. Parallel, coincident. And now you see when you move one, they both move the same. Now let's add the rotation. So if one motor spins, the other one will spin as well. To do that, we'll go back up to mechanical mates and we'll select the gear. Come in, select that circle, select the same circle in the other motor, We're going to leave it at 0.825. Say OK. And we go to spin the motor and it doesn't spin. And that's because, as they tell us in the book, these are fixed. So I'm going to do a rebuild right now to get rid of that. And what you do is you right click on them and select Make Subassembly Flexible. We do the same thing to both. Now when we spin this, both fans spin in the same direction. But what if we need one to spin one way and one to spin the other? Well, to do that, we'll modify that gear mate. Here, we come down to the gear mate. That's under the fan and housing, under mates and heliodrome assembly. And it's the last one we did here, the gear mate. So we edit that, and all we need to do is uncheck that reverse. So now, when we spin one motor, or one fan, the other one will spin in the opposite direction. And that's how you do a gear. And that's it for this exercise.